Page 34, activity 2.1, asks us to recall that a quadratic function is of degree 2. So you can see here in my quadratic example that I have, it's a second degree function. Remember, the degree is the highest power of its exponents. And this means that it has two zeros, or two solutions. And you'll find that to be true in Algebra 2 when you move into higher degree functions. A third degree function is called a cubic, and it has potentially three zeros, or solutions where y equals 0. And then a fourth degree has 4, and so on. So since it is a quadratic and it has two solutions, let's look at an example. X squared equals 9 is the example we'll look at. In order to solve that, if we were going to solve it algebraically, we would take the square root of both sides, right? Because if we do the opposite of x squared, that's square root. And my answer is going to be whatever the square root of 9 is. And you might not know this, but if you think about it, there's actually two square roots of 9. 9 is a perfect square. We know that 3 squared is 9. The other one, though, is negative 3, because negative 3 times itself is also positive 9. So the two roots, or the two solutions, would be positive and negative 3. Okay, that's doing it algebraically. We could also look at a graph. Before we do that, real quick, I want to talk about the axis of symmetry, because we're going to be relating the axis of symmetry to our quadratics going forward. The axis of symmetry in this case, question 1a, where is it? Well, it's that line right there. Remember, that's the vertical line that divides our parabola into two mirror images of one another. And that's located at x equals 0, because this is the parent function and it hasn't been shifted horizontally at all. Okay, so back to our question, though. If we were going to solve x squared equals 9, we could take inverse operations, which we did, and got positive and negative 3. Or, like we did on the warm-up, we can graph it. We can graph the left side of the equation, x squared, and the right side of the equation, 9. And let's do that. Take a look on Desmos here and see what it shows us. So I'm going to call the left side q of x is x squared. That's my parabola. And the right side of my equation, y equals 9. And I'm interested in where those two meet. And those meet at, as expected, both negative 3 and positive 3. There's the axis of symmetry if I wanted to include that into my picture. But graphically, that's one way of solving. I can look for the intersections like we did on the warm-up, or I could do it algebraically. Okay, so where does the graph, where do they meet? X squared equals 9. That we're looking for the intersection, those two locations. In this case, 3 and negative 3, or more succinctly, could be written as plus or minus 3, another way of writing it. Okay, well, what if we weren't asked 9? What if we were asked, when does x squared equal 2? I would approach it much the same way. Okay, I want to know where the graph of x squared equals the graph of 2, y equals 2. So I'd have a line down here at y equals 2. And if I went to the graph on the Desmos calculator, because it's a little more interactive, I can see that they intersect at negative 1.414 and positive 1.414. And those are the square root of 2. That's the decimal equivalent of the square root of 2. So we would say that the square root of 2 and negative square root of 2 are my solutions here. Which is more precise? We would prefer to use the square root because there's no rounding error involved. I know that that's not a particularly satisfying answer, but that's the best answer. If a quadratic function x squared equals 0, this is a situation where we would say it has a double root. That's kind of a weird situation, but that just means that the vertex is on the 0. So I can go back here. Let me go back and look at the graph real quick. So if I'm not looking at the where x squared equals 2, let's take that 2 off of my picture here, and we'll just talk about the where it equals 0. That's on the x-axis, right? So we would say, you could see that if you're approaching the parabola from the left side of the x-axis, we're approaching it at 0. And if we're approaching it from the positive side, the right side, it equals 0. So we call it a double root because we're approaching it from both sides. We get the same answer because the square root of positive 0 and the negative square root of 0 are both 0. There's no difference there. So that's called a double square root. That's a double root. That's kind of a philosophical concept. But if the vertex is on the x-axis, then we say it's a double root.